The researchers in UCL want to find others with similar research interests for purposes such as looking for partners in research work. However, this is a long process that currently requires a manual search and verification process that can take months. Our goal is to automate this process by allowing researchers to search for other academics using various filters, by web scraping UCL-related websites before cleaning the data and processing it into various forms of visualizations for them to use. As we are inheriting a legacy project, the previous team has created a web app interface that allows users to search for a module or publication based on a keyword search, a module and publication to SDG mapping, and a publication to IAG mapping with visualizations of data such as the blue. We have deployed this using Azure Web Services. Our key requirements. Firstly, we are changing the deployment host from Azure Web Services to Azure Virtual Machine. Secondly, a module and publication to healthy aging mapping. Thirdly, simpler visualizations for SDG and healthy aging mapping for clients that are non-technical. Here's a high-level overview of our data mining engine structure. We have a global controller that controls the managers, loader, modules, scopus, NLP, and Django sync folders, where each of them are compartmentalized and oversee actions related to themselves. It is to note that there are data interdependencies amongst components. For example, the output of scopus and modules is the input for NLP. Here is a run-through of the front end. A user requests for a resource to Django. Django works as a controller and checks available resource and URL. If URL maps, a view is called that interacts with the model and template and renders a template. Django responds back to the user and sends the template as a response. We use database management systems, PostgreSQL, MySQL, and MongoDB to store all data. We have a free subscription to MongoDB Atlas, which deploys MongoDB on a cloud. We have a Navicat to view our databases, Django to create a web app to present the data mining results to users in various visual formats, and Azure Virtual Machine subscription with 4 GB of memory where our databases, data mining engine, and web app will be deployed. For the visualization of the data, we design an intuitive bar chart and table combination that is easy to navigate and interpret. First of all, we are presented with an index where we are able to select the functionality that we want to run. For our purposes, we click on bar chart visualizations. By clicking on bar chart visualizations on either SDG or HA menu, we will get shown a list of bar charts containing information about the chosen topic. For example, if you select SDG 1, we will see the bar chart representing the number of modules per faculty that target that specific SDG. Or if we choose Faculty of Arts and Humanities, we will see the number of modules that target a specific SDG in that faculty. We are then able to click on the View Information button under the graph to reveal a table that breaks down the information in the graph into further detail, showing information like module code and the number of students. The same process applies to healthy aging goals. To summarize, for backend, we have created a module and publication to healthy aging mapping and loaded all necessary data for the front end into the database. We have also deployed the backend engine in the virtual machine and installed the necessary software and libraries. We have set up a task scheduler in the VM, which runs every year on the 1st of January to scrape and process the latest data and update the databases. This is for the convenience of our clients. For front end, we have made changes to the code for it to run on a local environment, created bar graph visualizations for SDG and healthy aging as they are easy to comprehend for non-technical users, and created Tableau visualizations for healthy aging. Thank you.